Hello everyone, I am going to make a presentation on safety system, and this topic will be on SIS overrides, bypasses, inhibits and MOS. This video is being taken on behalf of instrumentationtools.com and automationcommunity.com. Kindly watch and subscribe to the channel. What is SIS override? An override is a mechanism which is applied to prevent the action of a control or protection device, example a SIS transmitter. When associated with safeguarding systems, the application of such a device must be strictly controlled. In the normal scenario, all the SIS transmitters, SIS connected valves need to be in service. They have to be available because hazards can happen at any point of time. It is not a planned one, it is always an unplanned event. So all the transmitters, valves and associated SIS instruments need to be in service. In case due to any requirement for the maintenance reasons or some other equipment in this line, the particular line needs to be isolated, for which the transmitter or valve need to be isolated, those things will be taken out of service, so for which the override being applied. So below points to be kept in mind with SIS overrides. Overrides are managed and removed, normalized when they are no longer required. So they have to be carefully managed by a procedure. Overrides are only applied by competent personnel. Like anyone cannot make an override. There should be a competent personnel, or if the plant operators is doing this activity, this has to be informed to the shift supervisors, and if at all required to the shift manager, and depending on the type of override, it has to be approved by the operation manager as well. Overrides are not used to keep a system or equipment operational when the conditions are outside of the operating envelope or in an unsafe condition. See, normally these overrides are being applied whenever the plants are running in a safe mode. So if the particular area of the plant or some equipment goes out of the normal operating envelope, so in this condition we need to take care that the overrides should not be kept for quite long time. Overrides are handed over to the next shift if left in place during a shift change, because in the process industries, refineries, petrochemicals and other chemical industries, in the bigger plants, there are people working in the shift. It may be 8-hour shift, 12-hour shift, depending on the area and nature of the process and the geographical location as well. So override may be applied in a day shift. So the operators who are operating the plant is aware of the override which is being applied on a particular equipment or particular vessel. But if the next shift comes, the new operator who is coming in for the new shift may not be aware of this one. So the first shift operator who had applied the override need to inform the second shift operator to take care about this one, and as per the timeline and the maintenance procedures, this has to be restored back to the normalcy. So overrides are inspected and the status verified by supervision at a regular frequency. Like override is applied due to some reasons. It could be a failure of the instrument, it could be another equipment which is in the process need to be isolated for any leak or some supervision or inspection or any reason. So it has to be verified at a regular interval by the shift related person who are applying the override or who are in charge for the particular plant area, and as well as the maintenance personnel who are attending to the fault. Okay, and it has to be restored as soon as possible. Okay, what is SIS bypass? In SIS bypass, allow maintenance activities, calibration, proof testing or repair of a transmitter or other sensors to take place without a risk of a spurious trip. For safety's sake, the built-in functionality allows managing maintenance bypasses so that they are placed and removed at the right time. Bypass is another criteria wherein the calibration, proof testing or repair of a transmitter need to be done at a planned frequency. So as we all know, the SIS instruments are very critical for the plant and process, So they need to be regularly tested at the desired frequency, proof test frequency or visual inspection. Visual inspection may not have any impact, only for the proof test of the valves which are inline, and the transmitters, when there is a 1 out of 1 case, those transmitters may not be possible to get isolated. So in those cases, bypasses may be required for a shorter period of time to do the proof testing, to check the instrument healthiness and return back to the normal operation. So methods of better management of SIS bypass. Maintenance bypass timeouts and reminders can be configured to alert when a bypass timeout is imminent. Again, as we know, the bypass needs to be kept for a shorter duration, maybe for example 4 hours or 8 hours. It has to be completed within a particular shift. As far as possible, it should not extend to the next shift. Okay. Alarms can be configured to annunciate the operator when a maintenance bypass is active. Timeouts can be defined to either alert or remove bypasses automatically at a defined time, provided the SIS logics are intact, restored to operating conditions for plant safety. Most of the time there are some bypass arrangements in the HMI panel where the operators is doing the operations, like gas ductors in the plant can be isolated by the operations itself just by informing to the maintenance engineers or plant automation engineers. Whereas in some cases operations cannot do it, they have to be done by the respective maintenance supervisors or the plant operation automation engineers or instrumentation engineers who are responsible for the plant area. So for them they will be doing many tasks. The maintenance of bypass is one such activity. So whenever the time, they have to define a time, like 4 hours for transmitter maintenance, this is an example, or 8 hours to do the valve service maintenance and all. If it is not completed within that time, then alert has to be configured and it has to get alarmed in the panel so that the operators will be aware, and they may remind the maintenance personnel to go and finish that activity, go and finish the task and restore the SIS bypass. So this is the better management, so that the plant will be in safe conditions and it is ready anytime to take care of the hazards happening in case of any hazards happening in the plant area. What is Inhibit? In SIS, bypass by any other name is just as dangerous, whether referred to as an inhibit, suppression or forcing. The bypass of a safety system device or automated function nearly always means that this safeguard will no longer be able to provide the full degree of risk reduction and reliability it was specified to perform. As we all know, the SIS functions are built in such a way that they take care of any spurious trips happening across the plant due to some instrument's fault, due to actual operation reasons and those conditions. So that means it is taking care of the hazards which can occur anytime. That's why it's named, either name it by inhibit, suppression or whatever it is. So that has to be limited to a shorter time as far as possible. So what does it mean? The necessary spares also have to be kept in hand. Whenever there is any cord fault happening, a spare cord should be available in the stores always to go and replace immediately. Or there could be even a small fulcrum in a air regulator which may lead to leak and then may not be able to keep the valve in open position. So even such minute spares also need to be kept in stock either in the maintenance department or with the stores. So continued safe operation of that facility will usually depend on timely implementation of compensating measures to provide the risk reduction that was lost through the act of bypassing. Bypassing means we are just overdoing, or bypassing means we are just doing those instrument as if it is in live. Ideally, the instrument may gone out of service due to the maintenance reasons. Just to overcome and keep the protection active, it will be bypassed as if the instrument is healthy. For example, it's a 0 to 10 kg pressure transmitter, and at 8.5 kg per square centimeter, the trip is being programmed in the logic solver. The bypass will make in such a way that the pressure is reading around 6 kg on the particular piping or particular vessel. That is, it's not real actually. It's not a real process. Under the process, as per the operation sequence, operation phenomena, the pressure may get high sometime. So the control, if it is not controlled uniformly, there could be a chance of pressure getting high and leading to the hazardous event. But to take care of the maintenance of the transmitter, we are just forcing by the logic as if the process is healthy, and then taking care of the maintenance. So the maintenance personnel need to complete the job quickly and then return back the instrument to the normal operating condition. The timing is the most critical factor over here. The predictable consequence of bypassing a safety instrumented system device or function lead to the following dual requirements for bypass management: features to prevent and alert unauthorized use, and operator error. Actually, as we saw in the earlier slides also, there has to be some alarm mechanism or alert mechanism to alert the operations that the particular instrument under bypass. So, and it requires a management control, highly effective management of change and access security controls, because it will not directly go in for a bypass just like a normal case by word of mouth and all. Cannot be done. There has to be a written procedure. There has to be a written form. Either nowadays it is all electronic. It may be through some ERP system. So there will be a request coming to the shift manager. Shift manager will assign to the respective maintenance personnel or instrumentation personnel who is in charge of that plant area, and they will review it and see the other process conditions are okay to do the bypass and then do the bypass. Again, when everything is getting normalized, he has to close it in the system, which goes back to the shift manager to close in his end, so that the complete loop is getting completed. What is maintenance override switch? This is another one wherein the operations have the feature to override a particular scenario, particular equipment protection for a again shorter brief period of time. Maintenance override switch are provided to override all field input designated to trip the facility in order to facilitate maintenance of field devices without interrupting the plant operation. So this is done because the plants are running. You cannot, for doing a maintenance on a particular instrument, it is not wise to shut down the plant and bring up the plant, which may cost millions of dollars for the plant facility, and as well as it may cost a big group of team to work to make a shutdown and bring the instrument or bring the equipment back, process back into operation. So which means the time and money. So this is not advisable. So always the facilities are engineered in such a way that there are maintenance override switches are provided wherever is very critical, and the operations are trained and given a procedure to use this in a right time, in a right way. Below points to be kept in mind with SIS overrides. There shall be a common MOS key switch in the ESD operator panel. Have two positions. ESD stands for Emergency Shutdown System. That there will be an operation panel inside the control room. It will have a MOS key switch, which is maintenance override switch also, and it will have two positions. One position is MOS enabled and other one is MOS off. When the key switch is in MOS enabled position, there shall be a red status alarm in the ESD operator face panel, which shall flash until the MOS is turned off. The MOS should be in the off position, meaning need not be operated unless otherwise critically required. So whenever it goes into the enabled status, there will be an alarm to remind the operator that there is a MOS override has been done. So it will always alert the operators so that they will have in their mind to restore it back as soon as the work is completed. The alarm status of the field inputs which are overridden by MOS shall not be masked. MOS switches for multiple field inputs used in voting system shall be grouped together. See, there are many alarms which may be some nuisance to the operations and they may ignore it. They may silence it without giving much importance. But MOS should not be done like that way. That has to be given a critical priority and importance. The operations need to be aware which are the alarms related to the MOS, and they have to keep in mind that there is one override in the plant facility that has to be restored. If it is again delayed, the time is not completed within the allowed period, like it's not completed within a shift or something, they need to report it back to the operation manager, shift manager, and then to the maintenance personnel. That's why the alarm should not be masked. This is the word, this is the sentence meaning. So similarly, MOS switches for multiple failed inputs, because in particular area there may be some few 2 or 3 or few numbers of SIS protections may be happening, like SIS functions may be there. There could be a chance they can be grouped together, because for example there may be some gas detectors in the particular plant facility which are voting for a trip, either 2 out of 3, 1 out of 1, 1 out of 2, based on the need, based on the SIS calculations and all. So that they can be grouped, and then only one switch can be used. One particular pump or one particular turbine may have around 10 gas detectors around it. For each gas detector there need not be a separate switch. There will be number of switches and it will give confusion and chaos to the operations. So that gas detectors input can be grouped together on a single switch. Okay, here just we are seeing one picture about the maintenance override switches for your understanding. So this is emergency shutdown switch. Always it will be in the red color in the front, so that to operations and as well as the maintenance personnel know that it is in the normal off position. So whenever this is a switch positions what we are seeing, it's a normal position. The switch contacts are in closed position. That is why it's mentioned here. Main contacts means NC means normally closed position, and which is on, which is the healthy condition operating plant, so that the machine or equipment can operate. So it will not have a like SIS bypass or something. In this case, plants are running at a normal operation condition. Whenever any requirement comes or there is a procedure approves, then only maintenance override switches will be enabled or latched. Latch remains if you are seeing the contacts for here. See, here it is closed. Both the contacts here, what you are seeing is a contact, it's closed. In the other picture, it is a latch. That means the push button is pushed from its original position to the lock position, which is latched position. Here the main contacts becoming off. The NC contacts, which is NC earlier, here you are seeing the closed position. Here it becomes open. So in this case, machine cannot operate. So this is just for visual view of the switch. Here we are seeing some detailed view of the same switch. So there are three positions, not three positions, three different arrangements shown here. Here we are, what you are seeing is the operating element until this here, the switch, and then the locking mechanism, frame, other things, and here the contact block, which is a switch block, like we saw in the previous slide. So if you see in the normal condition and the button not pressed, button in the reset status or off status, there are different types of switches. This green line is visible. That could be different type. This is a different type of design. This is one design. So in this case, in this particular design, and the switch is not pressed and the green indication is visible, so that switch is in off position, the equipment is running, there is no bypass or no override. So here the switch contact positions, they are in the normally closed position, and you will see the other one. See, here we are seeing the assembled state and we are seeing the again assembled state, the switch. Here the button is being pressed, operation status, green light not visible, because when from the off position of the switch, we are some operation is doing a switch operation, MOS switch operation, by that it gets pressed. So joining together operating element and contact block with button being pressed maintain open the status of NC contact. From the closed position of this contact, here the contact becomes open. in this case the power coming through one end of the contact reaches to the other end and goes to the circuit to complete the circuit. Here in this case the power coming here cannot reach it because the contact gets opened. So this is the latched position or operating button pressed position and all, or stop position. Emergency stop means this is the stop position, this is the off position. And in the middle picture shows the same switch when it is detached, when it is removed, because here we are seeing the two different blocks. This is operating element blocks, which is a switch and the connecting components like a frame, panel, nuts, everything, and the bottom portion is the switch position, which is contact block. So in this middle figure what we are seeing is the detached state. That means the switch itself got some contact need to be cleaned or need to be inspected or need to be changed for any faulty reasons. So this is shown as a detached position wherein the contact block is removed separately and the operating element block is removed separately. Here we are seeing clearly the visible indicator of the green line. Button is not pressed in this case. Okay, this is just for understanding. Here since it is released, because there is a spring which is being pressed, and in this case when it is being pressed in its off position the contacts become closed. But here this is a detached position wherein the pressure tension is being removed and then the switch shows in the open position. Okay, this is for the understanding of how does the switch looks like. Okay, thank you very much.